Let's look at some properties of logarithm. Now, for any positive number m and b, where b does not equal 1, the following properties are true. The product property tells me that the log of a product is the sum of the logs. So log base b of m times n is log base b of m plus log base b of n. If I have a quotient, m divided by n, then that is the difference of the logs. So that's log base b of m minus log base b of n. The power property says log base b of m to the n is equal to n times log base b of m. Now this one's fairly straightforward to show. Suppose I write the log base b of m to the n is log base b of m times m times m dot dot dot. So we're going to have n of these. All right, using the product property, this is log base b of m plus log base b of m plus and on to log base b of m, where again I'm going to have n of these. Well, adding these up, this just becomes n log base b of m. Now, suppose I want to show the sum one. Let me let x equal log base b of m, and I'm going to let y equal log base b of n. So solving these, I'm going to get, writing this in exponential form, m is equal to b to the x, and n is equal to b to the y. So let me look at what m times n is. Well, substituting n, that's b to the x times b to the y. But I know, because I have the same base here, I can add the exponents. Now I have it in exponential form. Let me put it in logarithmic form. This tells me the log base b of m times n is equal to x plus y. But what were x and y? Well, log base b of m times n is x is the log base b of m plus the log base b of n. It's kind of a cool derivation. So how do we use it? Well, suppose I have the log base 4 of 32 minus the log base 4 of 2. I know that the log base b of m minus the log base b of n is just the log base b of m divided by n. So this becomes the log base 4, base doesn't change, of 32 divided by 2. Well, I'm going to simplify this. This is a log base 4 of 16. But this is the log base 4. I'm going to rewrite 16 as 4 squared. Well, this is 2 times the log base 4 of 4, and the log base 4 of 4 is just 1. So this is 2. What about 6 times the log base 2 of x plus 5 times the log base 2 of y? Well, the first thing before you can combine them, you have to get these coefficients and turn them into exponents. So this is log base 2 of x to the 6th plus log base 2 of y to the 5th. And now I can use the sum rule. This is log base 2 of x to the 6th times y to the 5th. Sometimes we want to expand. So if I want to expand a logarithm, I have a quotient here, so let me get rid of the quotient. This is the log of 4x minus the log of y. Now I want to point out there's nothing listed here. When there's nothing listed, this is log base 10. So log of x is log base 10 of x. All right, so to continue this expansion, I'm going to use the product rule here. So this is log of 4 plus log of x minus log of y. Oh, now what about something like this? Well, let me use the quotient rule first. This is log base 9 of x to the 4th minus log base 9, that's 9, of 729. I can use the exponent rule here, and bring this 4 back out to the front. So this is 4 times log base 9 of x. And there's nothing more I can do with that one. But what can I do about the log base 9 of 729? Well, it turns out 729 is 9 cubed. So this is 4 times the log base 9 of x minus, I'm going to bring this to the front, 3 log base 9 of 9. And log base 9 of 9 is just 1. So this is 3 log base 9 of x minus 3. Oh, excuse me, that's 4. Got carried away. That's what happens when you start working ahead. Do this in class all the time. 4. Now, I will point out that right here, you could have said log base 9 of 9 to a power is just a power. I'm okay with your taking that particular shortcut.